So now next theory point is about product of vectors. Product of here vectors. There are mainly two types of products. So first we discuss here, that's called scalar or dot product of vectors. Dot product of vectors. Scalar or dot product of vectors. You might have studied in physics also. Okay, so here we start with two non-null vectors. Let this be a non-zero vector, and the other one, this is also non-zero vector, non-null vectors. Okay, like this here. This is vector B, for example. This is another vector A here, making some angle theta between these two. Then their dot product is defined by this vector A dot vector B. We write dot clearly between these two vectors. We put dot between these two like this, equals to magnitude of first vector into magnitude of the other vector into cosine of angle between these two. You know this. This is known as dot product of two vectors. Okay. What's the definition of dot product? Magnitude of first vector. So this will be a number. This is also a number. And cosine theta is also a number. So this dot product of two vectors is a scalar, remember. Dot product of two vectors is a scalar here. So when you find the dot product of two vectors, your answer will be a number. So vector A dot vector B is a scalar. Scalar means what? It's a number. Dot product of two vectors is a scalar or number. Secondly, if you get this and if you find this, these two will be always equal, remember. These two are always equal. It means dot product is commutative. Order is not important. One more thing, sometimes we use this formula. I can write like this: cos theta equals to vector A dot vector B upon individual magnitude. Right? So sometimes this formula can be used to find the angle between two vectors. Right? To find, when we'll use the formula to find angle between two vectors. Angle between two vectors. When dot product we are given, we can use this formula. What's the formula? Cos theta equals to dot product of two vectors upon individual magnitude. So this formula can be used to find the angle between two. Cos theta equals to vector A dot vector B upon their magnitude, and here range of the theta, remember, whether it is here or here, it's from 0 to pi. Right? If the vectors are like this, for example, this is vector A, for example, this is another vector B, for example. So these two are in the same direction. So here theta is 0, remember. That's this extreme case. Theta is 0. If vectors are in opposite direction, for example, one vector is this is vector A. The another vector is in this direction. This is vector B. Okay, so this is angle between these two vectors. And what is theta in this case? Which is pi. If vectors are in opposite direction, vector A, here vector B, then the angle between two vectors is pi. If they are in the same direction, then the angle between two vectors is 0. In general, we use this formula to get the angle between two vectors. Okay. if two vectors are perpendicular, so one vector is like this here, this vector A, the other vector that's perpendicular to this. Perpendicular means what? Making a 90-degree angle. This is another vector B. So here vector A and vector B are perpendicular. That means here theta is 90 degree. Theta is 90 degree. So in that case, this will be cos 90 degree equals to vector A dot vector B upon their magnitude. Now this will be 0. This you can take over here. So vector A dot vector B. So this is a condition, remember. What's the condition? Vectors are orthogonal or perpendicular. This word is also used sometimes, orthogonal vectors. Orthogonal or perpendicular, that's the same terminology, remember. Perpendicular vectors means angle between two vectors is 90 degree. So vectors are orthogonal or perpendicular. Vectors are perpendicular if and only if their dot product is 0. Vector A dot vector B equals to 0. Vectors are perpendicular if and only if the dot product is what? 0. Vector A dot vector B is 0 if two vectors are perpendicular. That's one thing. Here one more thing, that is this. This is very important formula to get the angle between two vectors, remember. What's the formula here? Cos theta equals to A vector A dot vector B upon their individual magnitude, remember. So sometimes even this can be used to get the dot product, or this is the dot product. Dot product of two vectors is a scalar. It's a commutative, remember. One more thing here. If I note this next point here, that is if I find dot product of vector itself, so here theta will be 0 because two vectors will be parallel, so we'll get the magnitude of A into magnitude of A, so it is nothing but the magnitude of vector A the whole square. So this is always true. Dot product of a vector itself gives us the magnitude of this the whole square, right? So this is very important property again, right? These are all important results based on what? Dot product, remember. Sometimes dot product is also defined like this. If I take one vector A equals to with this components, let's take A1, A2 and A3. These are the scalar components. You can write like this: A1 I cap plus A2 j cap plus A3 k cap. You can write like this. If I take another vector B, let me write B1, B2, B3 as the scalar components. As the vector components, B1 I cap, you know these things, B2 j cap, B3 k cap. Fine. So then I'm just writing without proof. Dot product we can also write like this: A dot B equals to, take the corresponding components product, A1 into B1, A2 into B2, A3 into B3, and then you add them. This is the formula. This is another way of defining dot product. Even this can be used, remember. Right? So this you can find without getting the angle between two vectors, remember. Without getting angle between two vectors. What's the dot product here? Sum of the products of the corresponding components, remember. I repeat, sum of the products of the corresponding components. These into this, plus this into this, plus this into this. This is also a standard way of defining the angle dot product between two vectors. और ये देखो इसका आंसर एक नंबर ही आएगा. Therefore dot product of two vectors is always a scalar. I repeat, dot product of two vectors is always a scalar, remember. So here this into this plus this into this plus this into this, so we have dot product equals to this. Okay, this one. Second thing, dot product of a vector itself is magnitude of vector whole squared. That's also very important property, remember. This is also standard way of defining dot product. The another important one is two vectors are perpendicular if and only if their dot product is 0. Perpendicular dot product is 0 and reverse dot product is 0 means vectors are perpendicular. This is the formula to get the angle between two vectors, and this is another way of defining the dot product between two, remember. Okay, so if I just write simple example, if I take let's take vector A. I'm taking this 1 I cap plus 2 j cap plus 3 k cap, and then the vector B equals to, let me write here, 2 I cap minus 3 j cap plus k cap. So then your vector A dot vector B, that is here 1 into 2, you can rewrite like this if you want, 1 2 3, and here you can write 2 minus 3 1, right, in form of scalar component. These into this, which is 2, plus this into this, which is minus 6, plus here 3 into 1, which is just 3. So what we'll get here? Just 1. So dot product of two vectors is a scalar number, remember. Dot product of two vectors is a number. So here we are getting this. Okay. You can do even in R2 also. If I take, let's take vector C equals to 2 I cap plus 3 j, okay, in R2 only, and vector D equals to, suppose I'll write I cap minus j cap. Okay, so therefore vector C dot D, this was in R3, 3-dimensional, remember. Here we are writing where? In 2-dimensional. This is just 2 comma 3 if you want to write. And here this is nothing but the 1 comma minus 1. So 2 into 1, that is 2, plus 3 into minus 1, that's minus 3, so minus 1. So here dot product of these two vectors equals to what? Minus 1. One more thing, before I go further, as a remark you can write, even that's quite obvious to notice. Let me write as a simple note or remark here. If I consider for these three vectors I cap, j cap and k cap, if I get I cap dot j cap, what is I cap? 1 0 0 dot, what is j cap? 0 1 0. You know this. Now get the dot product. 1 into 0 0 plus 0 into 1 0 plus 0 into 0, which is 0. So we are getting 0 here. So I cap dot j cap equals to 0 here. So that means these two are orthogonal. Same way you can get j cap dot k cap, which is also 0. You can verify, not difficult. That means these two are orthogonal. If I get k cap into I cap, if I get this is also 0. Right? So this I, j and k, you know, these are the standard unit vectors in the direction of the three coordinate axes. They are perpendicular to each other. That we know. This is nothing but the direction of I cap. This is nothing but the direction of j cap. And this is nothing but the direction of k cap. In the direction of x-axis, y-axis and z-axis. So here these two are orthogonal, I mean perpendicular. These two are perpendicular and these two are perpendicular. The dot product is 0. That means these and these are orthogonal. Dot product is 0, orthogonal. Dot product is 0, orthogonal. Fine? Okay. So this is about dot product. Now here One more concept, that's a projection vector. Projection of a vector over the other vector. Projection of a vector on the other vector. We are defining projection of a vector over the other vector. So we take two vectors which are non-null, remember. We start with two non-null vectors here. So let me take two non-null vectors. Let's take vector A, which is not null, and another vector which is also not a null vector. We have started with two non-null vectors. So it's like this. Let me show you, making some angle. For example, this is one vector, this is another vector, making some angle. Let me show you like this. Okay, let me call this as vector. For example, here this is vector B, and this is nothing but the vector A. Now what's the projection? So projection is nothing but what? Adjacent vectors. That is, if I draw perpendicular from this to this, I'll draw one perpendicular from this vector to this. So this portion, this is a sum portion of the entire vector B. This is a vector B. The portion of the vector B, that's called the projection of A over this. This is perpendicular, remember. So this portion, this is called the projection vector. So with the concept of the angle between these two, here I'll write projection of vector A on B. It's given by this. Vector A into vector B upon the magnitude of this vector B. This is the formula. So it is, if you just rewrite, this is nothing but vector A dot, what is this? This is a unit vector. So you can write by the symbol B cap. B cap means what? Vector upon its magnitude. So vector A into, this is dot product, remember, unit vector in the direction of vector B. Is it? This is very simple formula here. What's the formula? A dot B upon the magnitude of B. Projection. So this here, this gives us what? So this is nothing but what actually? Magnitude of this projection vector, remember. So this is one. Same way, if I reverse this here, for example, this is vector, let me write this is vector, for example, A here. This is another vector B here. This is vector B. So I'll draw the perpendicular. So this much represent the projection vector, remember. So here projection of B on A, that's equals to here vector B dot vector A upon its magnitude. So you can just rewrite like this, dot product upon the magnitude of vector A. If vectors are orthogonal, then this will be 0. So projection is 0, remember. If vectors are orthogonal, then what happens to the dot product is 0. So let me write, if vectors are orthogonal, vectors are perpendicular. Orthogonal means what? Perpendicular. Then projection equals to 0. Projection equals to 0, remember. It's quite obvious, because if vectors are orthogonal, then this dot product will be 0. So this will be 0 in that case. Okay. Let me take one simple example here. Like if I take this example, the question is find projection of vector A on B, where A is this one. What's vector A? That is this one, 2i cap plus 3j cap plus 2k cap, and vector B is I cap plus 2j cap plus k cap. So in the solution, just you need to use the formula, nothing more than that. So projection of vector A on B equals to, let's use the formula. So here, which formula? You have vector A dot vector B upon magnitude of vector B, remember. How do we write the dot product? Very simple. 2 into 1, 2, plus 3 into 2, which is 6, plus 2 into 1, which is 2, upon magnitude of B, that's root of 1 square, 2 square, plus 1 square. So you have here, what do we have? 10 by root 6. That's a projection. That's one. Fine. So it's so simple. Just you need to get the dot product basically. Now one more question. Let's take A equals vector A is this, vector B is this. The question is find the angle between these two vectors. Find the angle. That's a question. Angle between these two vectors. So what is the formula here? Cos theta equals to, dot product upon individual magnitude. This is the formula to get the angle between two vectors. What's the dot product of these two vectors? 5 into 1, that's 5, plus minus 1 into 1, that is minus 1, plus minus 3 into minus 1, that is 3, upon magnitude of the first vector. What's the magnitude there? 25 plus 1 plus 9. What's the magnitude of the second vector? Magnitude of the second vector, 1 plus 1 plus 1. 1 square, and minus 1 square, you know it. So here numerator will be, what is numerator? It will be 5 plus 3, 8 minus 1, which is 7, upon, this is root 30, here this is 35 into here root 3. So therefore theta equals to, you can write cos inverse 7 upon root the product of these two, that's nothing but 105. You can live in this form. This is the angle between two vectors, right? Okay. Now I'll state two results about dot product. So first one, this is a very standard result, it can be proved also. For two vectors, for any two vectors A and B, this is always true. Magnitude of vector A dot vector B dot product is always less than or equal to magnitude of A into magnitude of B. This is a number, remember, so here no need to put dot. This is like 2 into 3. This is always true for any two vectors. This is called sometimes CS inequality. CS inequality. You might have used even in physics also. Cauchy-Schwarz inequality. CS inequality in vectors. Always true for any two vectors. Magnitude of dot product of two vectors is less than or equal to magnitude of this into magnitude of this. Okay, now the question is, can we get the equality here? In which case the equality holds, another way of saying. So I'll write equality holds in above inequality. This is in general less than or equal to. I'm saying that when equal to is possible, if one vector equals to multiple of the other one, where k can be any real number, remember. If one vector is a multiple of the other one, then we have equality and above inequality. Okay, that is either vectors are in the same direction or opposite direction. That is one. Second one, for any two vectors A and B, addition of these two, magnitude of vector A plus vector B is always less than or equal to magnitude of this plus the magnitude of this, right? Such things you did in complex numbers also. This is called triangle inequality. This is called triangle. This is known as triangle inequality. Which inequality? Triangle inequality. Remember, actually this one, and this one, this represent the three sides of a triangle. Remember, like this is vector A here, for example, this is vector B here, then you know that this one is nothing but A plus B, and you know, in a triangle sum of the two sides is always greater than third side. Therefore we have this is called triangle inequality. This is always true. Magnitude of the sum of the two vectors is always less than or equal to magnitude of vector A plus magnitude of vector B. Now here also, when we get the equality, that's the question. Equality holds in above inequality if one vector is a positive multiple of the other one. Here k should be positive, remember. K can be scalar, but it should be positive. What was there? K can be any number, remember. Negative, positive, both will do. Here it should be strictly positive. That means these three, A, B and C, should be collinear. This should be collinear. They must fall on the same line. Collinear points, remember. These 3 points must be collinear. If these 3 points A, B and C are collinear points, then you have actually equality in the above triangle inequality. This is always true, but when we get the equality in above inequality, if the points are collinear, that's same as one vector is a positive multiple of the other one. And in Cauchy-Schwarz inequality, here you have equality, one is multiple of the other, maybe positive multiple or negative multiple. Okay, now we go to exercise 10.3, which is very simple exercise again. So let's go for that. Exercise 10.3. Question number 1, first question. What is asked? Find the angle between two vectors. Right. There you are given their magnitude. Magnitude of vector A √3, magnitude of vector B 2, and dot product is also given to you. That's √6. So you have two vectors here with their angle equals to, say, theta. Okay, let's write theta equals to angle between these two vectors. So here we can write therefore cos theta equals to dot product upon individual magnitude. Straightforward, we are using the formula, remember. Dot product √6, here √3 into 2. So therefore cos theta equals to what we'll get here. You are left with root 2 by 2. So it will be just 1 by root 2. And therefore theta must be what? Pi by 4 or 45 degrees. So angle between two vectors here is pi by 4. Same way the next question. There you are given simply two vectors. So you need to get these three things, remember. We need to find these three things. So I'll take the first one as vector A. What is that? I cap minus 2j cap plus 3k. What about vector B? That is nothing but 3i cap minus 2j cap plus k cap. Fine. So what is the dot product? Product of the corresponding components, remember here. So 1 into 3, 3. This is plus 4. And this is plus 3. So how much we are getting? This is nothing but 10. Therefore here cos theta. What's theta? Angle between two vectors here. Right? This is vector A, for example. This is vector B. Then this is theta. So cos theta equals to dot product upon individual magnitude. What is dot product? Dot product, it is nothing but what? Here 10 upon magnitude of the first vector. What's the magnitude of the first vector? 1 square, 1 plus minus 2 square plus 9 into the other one. This is 9 plus, here 4 plus 1. So this is root 14 into root 14. So it will be just 10 by 14, which is 5 by 7. And therefore what is theta? Cos inverse theta. Cos inverse 5 by 7. We need to live in this form only. Fine. That's angle between two vectors. Okay. What about next question? Next question. Find the projection of one vector over the other vector. So let's take first vector as vector A. What is that? I cap minus j cap. And the other vector is I cap plus j cap. So projection of A on B, you know how to do this. Vector A dot vector B upon magnitude of vector B. What is dot product? 1 into 1, 1 minus 1 into 1 minus 1 upon magnitude is root 2. Magnitude, this is 1 comma minus 1, just for your information. This is 1 comma 1. How do we get the dot product? This into this 1, this into this minus 1, and magnitude of this is root 2. This is 0. That means vectors must be orthogonal. Remember, projection is 0 means what? Vectors must be orthogonal. I mean perpendicular. Okay, next fourth question. It's the same question. Call the first one is A here. Let the first one is vector A. Second one is vector B. Then the projection of vector A over the vector B, you can write like this. That is vector A dot vector B upon magnitude of B. I'm sure this you can do. Okay. What about next question? That's question number 5 here. Show that each of the given 3 vectors is a unit vector. So you can call that as vector A. What about the first vector? 1 by 7 outside as it is. Your 2i cap plus 3j cap plus 6a cap. I'll take the another one as B. 1 by 7. Then you have 3i cap minus 6j cap and plus 2k cap. Take the third one as vector C. Vector C is given by what? 1 by 7, 6i cap plus 2j cap minus 3k cap. Fine, I've taken these 3 vectors as A, B and C. Now you want to show that each of these is unit. So I'll get the magnitude of vector A. What's the formula for magnitude? 1 by 49 outside as it is. 7 square, 2 square, 4, 3 square, 9, 6 square, 36. So this is obviously 1. Same way, similarly you can show this. Similarly, just get the magnitude of B, which is also 1, and magnitude of C, you see it is also 1. Therefore, what's the conclusion? Therefore, these and this are unit vectors. That's the first part. Fine. And now what you want to show? You want to show that they are mutually perpendicular. How will show this they are mutually perpendicular? We get the dot product. What I'll do? I'll find vector A dot vector B. So what is that? 1 by 49 outside here, remember. 1 by 7, 1 by 7. Now 2 into 3, which is 6. 3 into 6. 3 into 6, which is minus 18. Plus 6 into 2, how much? 12 here. So this is 0. You can see. Therefore, vector A is perpendicular to vector B. Same way, you show that B bar dot C bar equals to 0. It implies vector B is perpendicular to vector C. And you show that vector C dot vector A equals to 0. That means vector C is perpendicular to vector A. Right? This much I leave it to you. I'm sure you can do it. Okay. The next question, question number 6. Let's do the 6th question. So in the 6th question, find the magnitude of A and magnitude of B. This is the question. You are given this. This is given to you. Equals to 8. Now we'll use just distributive property. See, I'll open the bracket. Vector A dot vector A minus vector A dot vector B plus here B dot A, vector B dot vector A minus vector B dot vector B equals to how much? 8. What I did, I have just opened the bracket, remember. Nothing more than that I did. What I did, A dot A minus A dot B plus B dot A, this. Now what is A dot A, do you remember? It's the magnitude of A whole square. You know that these two are always equal. So this will get cancelled. Minus, what is B dot B? That's magnitude of B the whole square equals to 8. I've used which property? Magnitude of, dot product is commutative, remember. That concept I've used. So therefore you could cancel this too, remember. Fine. One more condition you are given here. Which condition you are given in this question? One more condition you are given. That is, call this as 1. And what is that condition? Magnitude of A equals to 8 times magnitude of B. This is given. So we just use these two. So from 1 and 2, just I'll place the value of this one over there. So you'll get the 64 into magnitude of B the whole square, squaring this, minus magnitude of B whole square equals to 8. So 64 minus 1, that's 63 magnitude whole squared equals to 8. Fine. So what we'll get from this? Magnitude of B equals to, you have, what we have? Root 8 upon root 63. Just taking square root. And therefore magnitude of B equals to, you remember magnitude of B is positive. That's where you cannot have plus or minus sign. This is positive. Even though you have taken the square root, still 8 is 2 root 2, you know. And you know here, this is nothing but 9 sevens are. So 9 will come out, it becomes 3. 3 root 7. This is the magnitude of B. And now, therefore, magnitude of A will use this. Equals to 8 times magnitude of b, but magnitude of b you already did, that is 8 into 2 root 2 by root 3 root 7. So what we'll get from this, you will get the 16 root 2 by 3 root 7. That's your answer. This is nothing but the magnitude of a. Right. Magnitude of a is this and magnitude of b is this. The important one is this first step, which is distributive property. Remember, commutative property I've used. This already mentioned earlier. A dot A is magnitude of A whole square. Vector B dot vector B, that's magnitude of B the whole square. Okay. Next question. Question number 7. Evaluate this product. So it's the same thing. Just you need to use what? Distributive property. The question is evaluate this. Evaluate what? 3 vector A minus B 5 vector B dot 2 times vector A plus 7 times vector B, remember. So we'll just, like the previous question, we'll just open the bracket. Okay. So this with this, which is how much? 6 vector A dot vector A, remember. This is how much? 21, 3 into 7, vector A dot vector B, minus here 5 into 2, 10 times vector B dot A, but B dot A is same as A dot B. And finally here minus 5 into 35 vector B dot vector B. Fine, just opening of the brackets, remember. Now this 6 as it is because it's a scalar. What is this? Magnitude of A whole square. 21 minus 10, which is 11, dot product of these two. What about the last one? That is nothing but what we'll get? There 35. And what is B dot B, which is magnitude of B the whole square. That's required evaluation. Right? That's what you are asked here to find. Okay. What about the next question? Question number 8. 8th question. Find the magnitude of two vectors having the same magnitude such that the angle between two vectors is 60 degrees and the scalar product is half. Okay, so you are given this. What's given? Angle between two vectors. Angle between two vectors, that's given to you. That let me call the theta, which is 60 degrees. Scalar product means what? Dot product. So vector A dot vector B equals to half. What you are asked to find? Please read the question. What you are asked to find? You are asked to find what? Their magnitude, having the same magnitude. So to find this, to find magnitude of A equals to magnitude of B. This is what you want to find. ये दोनों find करने हैं और दोनों equally होगा. That's given in the question itself. So just use the formula. Using which formula? Angle formula. Cos theta equals to vector A dot vector B upon their magnitude. You know this formula. The cos 60. So here let me write cos 60 degree. Numerator, you know, you are given half. This one as it is. This is also half. So this will goes away, remember. So magnitude of A into magnitude of B equals to 1. But these two are equal. That's given in the question. So therefore, this one equals to this and both of them has to be 1. That's what you want. Both of this must be 1 because both are equal, remember. So just if you want, you can write here. This given in the question itself, they are equal. This is given. So their product is 1, both are equal. So therefore both of them must be 1.